So what did we do? So the light microscope technique that we invented is based on the idea called fluorescence microscopy, where you can label a particular part of your sample with a fluorescent dye molecule. And for example, if I want to see the filaments within the cell, I can label the filaments with a green fluorescent dye. And when I look at the image, I see the filaments standing out with high contrast. And so this is the idea of the fluorescence microscope, is that you tag your sample with specific fluorophores to the specific targets you want to see. Now, early in my PhD, I made the surprising discovery that a particular fluorophore can be switched on and off like a molecular switch. It really acts like a light switch. You can turn all the fluorophores off and they all go dark. But you can turn a few of them on, and then you can see just those individual fluorophores. Now, we weren't sure exactly how this was going to be useful at first, but we studied the switchable fluorophores, and we began to understand their properties. One day, a friend of mine sent me a review paper about high-resolution fluorescence imaging, where you could get this really high detail in your image. And at the very end, one of the things it suggested was that next generation high-resolution imaging techniques we're going to make use of switchable fluorophores, such as the one that we had discovered. And so we began to brainstorm about ideas. How can we use fluorescent molecules that you could switch on and off? How could we use those to make high-resolution images of biological samples? And so here's the idea we came up with. Label your cell as before. Label the sample with fluorescent dyes. Switch them all off, so you can't really see anything in the image until you switch just a few of them on. And now I see points of light in the image, each one corresponding to a single fluorescent molecule. I can find the positions of those molecules because I can see I can see just an individual point. I can just find the center of the point that I see, and I can record the coordinates, switch those fluorophores off, and switch a different set on. Find their coordinates, switch them off, and repeat the process each time, finding a new set of coordinates, a new set of molecular positions. And as I'm building up more and more positions of these fluorophores, if I plot the coordinates of the positions that I found, of the fluorophores that I found, I can connect the dots with the coordinates I see. And this coordinate map, it's a new type of image, and it's reconstructing an image of your sample, but without the resolution limit that the light microscope was previously subject to. The images we get by plotting the coordinates of the fluorophores, this image isn't resolution limited. In fact, there's no limit to the resolution you could achieve in such an image. And that's what lets us see the finest detail of the structures within the cell. That's the basic idea. In the next 5 to 10 years, I think that the prospect of having a small research group with graduate students thinking about the science on a little bit of a higher level and teaching and advising students, would be a very rewarding and satisfying thing, and that's what I'm looking forward to. I think my best advice would be that if you have a vision of particular science you want to do, or a particular way in which you think you can apply your skills and apply your ideas to solving problems, you should really pursue that. I think in my case, I felt that my background in engineering and physics could make a contribution to studying biology, and I think we were successful. I was very satisfied with that. Winning the prize is great exposure for our research, and getting different biology groups around the world interested in this technology and its applications, I think that's one of the one of the big rewards of the prize, is just spreading our ideas. But also, it's a recognition, and it's sort of very satisfying to know that our research is important and making a difference for the broader scientific community.